Good evening students, welcome back to the class. Today we'll start a new chapter, that is equilibrium. In order to understand the meaning of equilibrium, we have to consider an example which I have drawn to your left. This is a beaker with a closed lid. Now I have taken some liquids. As you know that the liquids tend to evaporate and they also condense. Since the beaker is closed here, the liquid that is evaporating, those evaporating molecules, those gas molecules will strike the walls of the container and they will tend to condense. So you can see here two processes are occurring. One is your evaporation and another one is your condensation, right? So two reactions are going together. Now you will reach a certain point when of the chemical reaction when the rate of evaporation becomes equal to the rate of condensation. It means that the number of molecules that is present as liquid and the number of molecules that is present as the gas, the ratio will remain constant. They won't change because the rate of evaporation is equal to the rate of condensation, and that does not mean that the number of liquid molecules is equal to the number of gas molecules. No, it is not so. But yeah, the number after the attainment of the equilibrium will remain constant. Suppose if 10 molecules are there in the liquid state and 5 molecules are in the gaseous state, then this ratio will be maintained. Is it clear? The number will not be same, but the ratio, the number of the individual types of molecules will remain constant. So that point is known as the equilibrium stage. So I have already written here rate of evaporation is equal to rate of condensation. Now let us consider a reaction where A plus B are the reactants, C plus D are the products. As you know, A plus B is reacting together to give us C and D. Okay, A molecule and B molecule is reacting to give C and D. Now when we talk about equilibrium, C and D again react among itself to give us A plus B. Okay, so it means that there are two reactions going on here. One is the forward reaction from AB to CD and another one from backward reaction. C and D is reacting to give us A plus B. So when we talk about the forward reaction, A plus B are the reactants, C and D will be the products. When we talk about the backward reaction, we have to go reverse direction. So in this case, C and D will be the reactant and A and B will be the products. And the sign of equilibrium is it is a half arrow, inverse or reverse half arrow. Is it clear? Here the rate of the formation of C and D is equal to the rate of the formation of A and B. Clear? So this is known as the equilibrium. Now let us talk about the law of equilibrium, chemical equilibrium and equilibrium constant. As we have already considered the reaction A and B reacting to give us C and D, reverse C and D is reacting to give us A and B. Okay, now when we talk about the equilibrium constant, it is equal, the equilibrium constant is equal to the multiplication of the concentration of the products. Now you don't get confused, here it is plus, okay, because it's a reaction. But when you talk about the equilibrium constant, you cannot put a plus here. Many of you do the mistake. The previous students used to do this mistake by some I don't know what they think about it, but they tend to put the plus in between. So this thing you have to keep in mind, there is no plus in between when we express the equilibrium constant. In the reaction it is, but don't forget, in between the multiplication of the concentration, there it cannot be a plus. Okay, so the equilibrium constant is equal to multiplication of the concentration. Concentration we denote with this bracket. Okay, this bracket is the symbol for concentration. When we talk about the concentration of C, we have to put it within a bracket. Okay, and it is usually expressed in mole per liter. So there will be some amount of C, some amount of the amine concentration divided by the multiplication of the concentrations of the reactants. Is it clear? Above it is the multiplication of the concentration of the products, and in the denominator it will be the multiplication of the concentration of the reactants. Clear? And this expression is known as the equilibrium constant expression. So you will get a constant value here. Now, in order to be more general, let us consider A, B, B. Now, what is this A, small b, small c? So, I have written one example here. You can see if half of nitrogen reacts with 3/2 of hydrogen, it will give us ammonia. Clear? Now, these coefficients that you can see, these constant terms that are in front of the symbols, atomic symbols, molecular symbols, these are the coefficients. Clear? Stoichiometric coefficients that are used to balance the reactions. So there is an important role that these coefficients play in expressing the equilibrium constant. Okay, now what happened, the coefficient becomes the power of the particular concentration of the reactant. You see, we have written the same thing here. This is the concentration of C, multiplication concentration of D, and both these are products. Now, this C becomes the power. Okay, suppose this C 5 moles per liter. Suppose the concentration of C is 5 moles per liter. Then, since the concentration of C to the power C, suppose here it is 2, then it will become 5 to the power 2. Is it clear? So whatever coefficient is there, that becomes the power. Similarly, for A to the power A, concentration, whatever concentration, and there will be one numerical value, that value will become the power of that concentration. Clear? For example, H2 plus I2 equilibrium to HI. So, if we talk about equilibrium, as you know, here two reactions are going on. H2 plus I2 reacts together to give us 2HI. And if we go in the backward direction, 2HI reacts together to give us, there are 2 moles of HI, okay, HI plus HI. So these two HI reacts together to give us H2 and I2, hydrogen and iodine. Now your Kc will be, let us see what the product is, HI. So you have to put HI. Now we are going to use the concentration of HI, therefore you have to put a bracket here. Now let us see if there is anything in front. Yeah, there is. So it is a 2. That is the coefficient which will become the power. Clear? Here H2, there is no any means coefficient. The coefficient is 1. So no need to put here 1. Okay, it's understood here. So H2, concentration of H2 into concentration of I2. There is no coefficient here. This is depicted with Kc, that is the equilibrium constant. Now, if you have realized one thing till now, that we are talking about the forward reaction here. As I have already said, there is a backward reaction going on, so we will get another equilibrium constant for the same chemical reaction, right? The one that is going from the forward, from HI to H2 plus I2 to HI, this is the Kc. If we see in this direction, in the backward direction, now this becomes the reactant. Clear? So let us consider that the equilibrium constant is expressed as Kc dash, which is equal to concentration of H2. Now you see here in the backward reaction, these are the products, this is the reactant, so the product concentration will be in the numerator. So H2 into I2, and below will be the concentration of the reactant, that is our HI, and 1 2 is there, so that will become the power. What you have concluded here is that it is reverse, right? It is means 1 by Kc will give us Kc dash, because this is just a reverse. Clear? It is like 5/2 and this will be 2 by 5. Clear? So it is what? 1 by 5 by 2 means 2 by 5, isn't it? So you will get one thing here. Kc is equal to 1 by Kc dash. So both are reverse here. Or you can also write that Kc dash means the equilibrium constant for the backward reaction is equal to inverse of the equilibrium constant for the forward reaction. This is the thing that you can interpret here. Let us consider one more example for better understanding. 4 ammonia is reacting with 5O2 to give us 4NO plus 6H2. So this is the set of reactions that are given to you. Now the question is, write the equilibrium constant expression for the following reaction. So what is your first thing to see if there is mention for the forward reaction or for the backward reaction? If it is mentioned that you have to calculate the equilibrium constant for the forward reaction, then you have to go this way. Clear? So when you will go from this way, these are your products which will go in the numerator. That is this is the product, NO and H2O. So NO, H2O. Now you have to see the coefficient. Yeah, there are coefficients. So this will become the power of the respective reactants. That is your 4 NO, and this is your 6. So 6 is with H2O. So it will become the power of the concentration of that particular reactant product. Now in the reactant it is NH3. Coefficient is 4. So 4 will come here. Now O2, okay, so 5 is there, so 5 will go in the product, in the power, okay. Now if it is asked that calculate the equilibrium constant for the backward reaction, then you cannot do this will go wrong because your backward reaction is this way. So this will become your reactant and this will become your product. So the inverse of this will give us the backward equilibrium constant. I hope you have understood the class, and it is a very important class. Questions are asked from this portion. I hope you have understood, and if there is any problem you can always approach me, as I always say. Okay, thank you.